So the first thing, they ask you to convert the point from cylindrical coordinate to rectangle coordinate. So they give you the cylindrical and they ask you to convert to rectangle coordinate. Convert the point from cylindrical. Yeah, so you see, I'm going to use exactly this formula from cylindrical to rectangle. So the point now, this is question 1. They give you a point which is 705, 7, 0, and -5. That means we need to write down the rectangle. We need to write down x, y, and z. That means this is rho, and here is theta, and here is phi. Now we need to find x, y, z. With the cylindrical, x is going to be r cosine theta. Oh, this is the r. R, this is not spherical, it's cylindrical. So this is one r, and here is theta, and this is z. So x is going to be r cosine theta. That means going to be r, which is 7, cosine theta is 0. And the result is going to be cosine 0 is going to be 1. That means it's going to be 7 times 1, and the result is going to be 7. Now y is going to be r sine theta. It's going to be r, which is 7, sine theta is 0. And this one is going to be 7 times 0, and it's going to be 0. That means x, y, z is going to be x is 7, y is 0, and z is going to be exactly the same one. So it's going to be -5. So here's the point we converted from, because it depends about the theta, from cylindrical to rectangle coordinate. That's it for the first one. So we're just gonna plug in 7, which is now the same point, comma, and -5. This is for the first one. Why just 7? For the second one, we need to convert the point from cylindrical coordinate to rectangle coordinate. Exactly the same thing. Cylindrical to rectangle. So the second one, the point is 6, -3 pi over 2, and and 5. So this is the cylindrical coordinate. We need to convert to rectangle coordinate. So x, y, z. That's what we need to find. So that means this is r, this is theta, and here is z. Z is going to be exactly the same one. We need to find x. X is going to be r cosine theta. Now it's going to be r cosine -3 pi over 2. So it's going to be r is 6. So plug in everything exactly the same thing. So r is 6 cosine theta, which is going to be -3 pi. Here is -3 pi divided by 2. I have to close the parentheses. So it's going to be 0. That means 6 times 0, and the result is going to be 0. So x is 0. Now y is going to be r sine theta. So it's going to be r is 6 sine theta, which is -3 pi over 2. And this one is going to be 6 sine this number, which is, so the same one, but it's going to be sine. I can't. So 6, it's fine, just sine negative 3 pi divided by 2 is going to be 1. That means 6 times 1, and the result is going to be 6. So now I have the sine and the cosine. That's mean x, y, z is going to be x is 0, y is 6, and z is going to be the same one, which is 5. So that's it for the second one. So this one is going to be 0, comma, 6, comma, 5. That's mean this point in the cylindrical coordinate is going to be 0, 6, 5 in the rectangular coordinate. The third one, question 3. The point is 5 square root of 2. And the next one is negative 5 square root of 2. And 3. We need to convert from rectangle to cylindrical coordinate. That means we need to find the radius, the theta, and z. The z is going to be the same thing, but we need to find r and theta. So the formula says r squared equal x squared plus y squared. Now, here's the point. This is x, this is y, and this is z. That means r squared is going to be x squared, which is 5 square root of 2 squared plus y, which is negative 5 square root of 2 squared. That means r squared is going to be, this is 2 times 25, so it's going to be 50. So that means 25 times 2 plus, square this one, also 25 times 2. That means r squared is going to be 50 plus 50. So r squared is going to be 100. R is going to be 10. That means the radius is 10. Now we need to find the theta. We have formula says tan theta equal y over x. Then theta is going to be, this is important thing how to find, because you can't plug in the theta and decimal number. We have to convert it like pi over 2 radian, 3 pi over 2. So tan theta is going to be tan inverse y over x. That means theta is going to be tan inverse y is negative 5 square root of 2 divided by 5 square root of 2. That means theta is going to be tan inverse to the negative 1. Let's check that. Tan inverse to negative 1. Do exactly the same steps. If you're using the 36 Pro calculator, it's going to be easier. So what I'm going to do here, I need to find the tan inverse to the negative 1, close the parentheses. So it's going to be, you see this number. It's a really long number. I can't plug in this one on WebAssign. You're going to tell me wrong. Theta is going to be equal negative 0.78539.8163374. I'm writing down the whole number. I can't plug in this number. So what I'm going to do, I'm going to convert it to the radian. I'm going to divide this one by pi. So divide this number, divide by pi. So it's going to be, we'll do this one on the side. So you can remember negative 0.78539, the whole number divided by pi is going to be equal negative 0.25. If you check this number, negative 0.25, it's exactly like negative 1/4. So this one is negative 1/4. That means our theta is going to be, theta is going to be equal negative pi/4. So here is the theta. Now here is the theta. I can the 0.5 square root of 2, negative 5 square root of 2, and the 3 is going to convert to the r is 10, and the theta is negative pi/4, and z is going to be the same thing as the 3. So that's how we're going to write down the theta. If you have another way to write down behind the theta, it's up to you, but you have to use theta equal tan inverse to -1. This number you can't plug in the WebAssign. You have to convert it to a pi over negative pi/4. So I'm just going to plug in here 10, which is r, and comma, I have to plug in here negative. I think here it's going to be negative pi. How are we going to write down the pi? Here's pi over 4, and comma, z is going to be the same, so it's going to be 3. So this is for example 3. I think we're going to do exactly the same thing for example 4. Convert the point from rectangle coordinate to a cylindrical coordinate. So exactly the same thing, rectangle to cylindrical coordinate. Let's check that on example 4. You can do exactly the same steps for this example. X squared plus y squared. So r squared is going to be 7 squared plus negative 7 squared. That means it's going to be 49 plus 49, 49 plus 49, and I need to find a, so take the square root for this one is going to be like 7 times 2, so it's going to be 7 square root of 2. So it's going to be 9, 8. That's mean r squared is 9, 8. R, take the square for both sides, is the square root of 49 times 2. So r is going to be 7 square root of 2. So this is the radius. Now we need to find the theta. Theta is going to be tan. Let's write down the formula first. If you want to use this one, it's going to be right. Tan theta is going to be y over x. That means theta is going to be tan inverse to the y over x. So theta is going to be tan inverse. Y is negative 7 over 7. So theta is going to be tan inverse to the -1. Then theta is going to be exactly the same number we got it before. So it's going to be, the number is negative 0.7853 and keep going. We can't use this number, so I'm going to divide it by pi. I'm going to say theta is equal negative 0.7853 divided by pi, which is equal negative 0.25. And this one is equal negative 1/4. That means the theta is going to be negative pi/4. So the point 7, negative 7, and 4 is going to be converted to the r is 7, square root of 2. Theta is going to be negative pi over 4. And z is going to be 4. That's it for this example. Exactly the same steps. You just have to be careful here. So I'm going to say it's 7 square root of 2, 7 square root of 2, comma, negative. So the same thing is going to be negative pi over 4 and comma 4, which is the z, is going to be the same one. If you check the next example, find the equation of the cylindrical coordinate for the surface by the rectangle equation. So we have rectangle, we need to find the cylindrical equations. Check example question 5. The equations we have is z equal x squared plus y squared minus 5. That's the equations in the rectangle coordinate. We need to write down the cylindrical coordinate. So what I'm going to do, we have already one of the formulas. It says r squared equal x squared plus y squared. So I can plug in instead of x squared and y squared is r squared. That means z is going to be, everything here is r squared minus 5. Z is the same thing on the cylindrical coordinate. It's the same z. So now this equation is the cylindrical equation. So this one, cylindrical equations. So that's it for this example. They ask you the same thing. Find the equation in cylindrical coordinates. That means we have the rectangle. So question 6, we have the rectangle coordinate and we need to find the cylindrical. Y equal x squared. So now, how are we gonna change this one to cylindrical coordinate? I already know y is r sine theta. And x is r cosine theta. So I'm going to use these two formulas. That means this side is r sine theta equal r cosine theta squared. So it's going to be r sine theta equal r squared cosine squared to the theta. I'm going to square these two terms here inside the parentheses. So next step, I need to find all the numbers in cylindrical coordinates. So I'm going to divide both sides by r cosine square theta. So I'm going to divide this one by r squared or r cosine square to the theta, and divide this one also by r cosine square to the theta. Check on this side, cancel this one with this one, square with this one. The left is just r. R equal, on the other side, you're going to cancel the r with the r. The left is sine theta over cosine square theta. Now, r is going to be, I can write down this sine theta over cosine theta times 1 over cosine theta. So r is going to be, this is the tangent. So it's going to be tangent theta. And the other one is going to be times secant to the theta. So now check. R is cylindrical coordinate, tangent with the theta. and secant to the theta, all these, the theta is in cylindrical coordinate. That means we did convert from rectangle to cylindrical, and this is the equations in cylindrical coordinate. The same thing is going to be on the next one. Example 7. From rectangle to cylindrical coordinate. So question 7, we have x squared plus y squared plus z squared minus 7z going to be equal to 0. Now we need to convert this one to cylindrical coordinate. So what I'm going to do, I need to find the right formula to convert everything to cylindrical coordinate. Now, if you look, this one is cos r squared equal x squared plus y squared. That means this is r squared. Z and z is the same thing in the cylindrical coordinate. That means it's going to be r squared plus z squared minus 7z equals 0. I think you can keep it like this, or you can write down as a r squared equal 7z minus z squared. Both supposed to be right. I forgot to check this one here. So which is r equal sine theta not sine, tangent theta. I'm gonna find the theta with the symbols and close the parentheses and secant. Here is the secant and here is the theta. So secant theta. And the next one is going to be the next one. This one is going to be r squared, or you can say r squared. Let's check the first one, r squared plus z squared. So plus z squared minus 7z equals 0. This one's supposed to be right. So next example, we need to find which one is going to be the right graph for this equations r equal 8. The next one is find the equation in rectangular coordinate for the surface, and then you have to sketch the graph. So let's see r equal 8. So the first thing we're going to do, we need to find the equations. So we just have r equal 8. So r, I'm going to square both sides. If you want to don't square both sides, you have to put square root for x squared plus y squared. So I'm going to square both sides. It's going to be r squared equals 64. That means x squared plus y squared equals 64. So I already know this is a circle, but I need to find a cylinder equation. That means in this case, I have xy. I need to find the z. In this case, we don't have to find the z because this is the cylindrical equations for this one. X, Y, Z. That means we can choose z is any number. To find the graph. R is 8, radius is 8, z is any number. So we're going to depend about the radius to figure out which one is going to be the right one. So let's look here. The radius is 8. That means both sides is going to be 8. But if you look, z is going to be any number. Z here is 5, 6, 7, 8. 8. Z from the bottom is 8. We can choose Z is 8 because Z on this equation, it's any number. You can choose Z8. So we can choose this one. It's a cylindrical, so it's going to be this one or this one. This one is, let's check the radius. The radius is 8. Let's look this one. This is less than 5. This one is less than 5, so we can choose this one. If you look to this part, the cylinder, we check here is the radius 8. This one is 8, 8, 8. So the circle here is right. Z is any number, so we're going to choose this one. First of all, I have to write down the equations, which is x squared plus y squared equal, you can write down 64. Let's check if this one they're gonna accept it. It's supposed to be they accepted. That's it. This one's right. This one's right. It doesn't mean this is the graph right. This is mean the whole part is right because we choose the right option. So let's check example 9. We have r squared plus d squared equal 3. So I already know this is cylindrical coordinate equations. I need to write down the rectangle. So we already know r squared equal x squared plus y squared. So I'm just gonna plug in here x squared plus y squared plus z squared equal 3. That's it. I don't have to move on. Just keep it like this. This is rectangle equations. Now the other part is how to find the right equations. So here is x squared plus y squared plus z squared equal 3. That's it. We're done from this one. X, Y, Z equal 3. X, Y, Z equal 3. So the radius, if you move this one, the height, so it's going to be 3. So we can choose this one. We can choose this one. It depends about one of these. What do you think? Which one is going to be the right one? This one or this one? Okay. I'm gonna choose this one. Okay. So I'm talking about radius equal the square root of 3, which is equal 1.7. Let's check this one. I'm talking about the circle x, y. I'm not gonna care about the z. So here is 1. This is 1.5. This is 2. So 1.7 is supposed to be here, right? So that means I can choose this one. Let's check this one. This is 1. This is 1.5. This is 1.7. So the circle on xy coordinate, this is xy coordinate, this is right. That means the right answer is going to be this one. You got it? Yes or no? So we're gonna convert the point, which is the point is, this is 10. The point is 400. We're gonna convert from rectangle. So this is x, y, z. to spherical, which is the point is going to be rho and theta and phi. So we're going to convert this one. We need to find this new coordinate. That means this is x, y, z. So the first formula is going to be look like rho squared equal x squared plus y squared plus z squared. So the rho squared is going to be x squared is 4 squared plus 0 squared plus 0 squared. Rho squared is going to be 16. Then rho squared is going to be 4. So the first point here is 4. Now we need to find the theta. The same thing, tangent theta equal y over x. Theta is going to be tan inverse y is 0 over x is 4. That means theta is going to be tan inverse is 0. And in this case, theta is going to be 0. So I have theta equals 0. Now the phi is going to be cosine inverse. This is the formula. Z over square root of x squared plus y squared plus z squared, which is going to be equal cosine inverse z equals 0. That means 0 over x squared. I'm not going to plug in that because x squared plus y squared plus z squared, 0 divided by any number is going to be 0. That means phi is going to be cosine inverse to the 0. Let's check that. You're going to do exactly the same thing. Cosine inverse to the 0 is going to be this number. That means phi is going to be 1.570. Let's check the whole number. 707963268. This is the whole number. 68. I already convert this one. Yes. Now we're going to divide this number by pi. So I'm going to say this is divide. This one is divide by pi. To convert it to the radian, it's going to be half. That means pi is going to be 0. This one equals 0.5. And this case, the phi equal pi over 2. And z is going to be the same number. So x, y, z, or let's write them as a point, 400 is going to be phi is 4, theta is pi over 2, and the phi is going to be, no, the theta is 0. And phi is pi over 2. That's it for this example. So let's check that. Example 10 is going to be 4, 0, pi over 2. Pi divided by 2. That's mean 90 degrees. That's it for this example. So the same thing, convert the point from rectangle to spherical coordinates. And the point is -2 and -2 and 19. Square root of 19. So the point is -2, -2, and square root of 19. We need to find the rho and the theta and pi, which is the spherical coordinates. The same thing, the first thing I'm going to start finding the rho, which is p squared equal x squared plus y squared plus z squared. So rho squared is going to be negative 2 squared plus 2 squared plus square root of 19 squared. This one squared is going to be 4 plus 4 plus 19. And then it's going to be rho squared is going to be 27. Take the square root for both sides. So it's going to be 3 square root of 3. I'm done from this one. The second part, we're going to find the theta. So tangent theta is going to be always y over x. Theta is going to be tangent inverse y over x. That means theta is going to be tangent inverse y is negative 2 divided by x. So negative 2 divided by negative 2. That means y is going to be equal theta tangent inverse to the 1. Tangent inverse to the 1, let's check that, how much is going to be. That means the tangent inverse to the 1 is going to be this number. That's the important thing. So theta is going to be 0.78539 and keep going. I need to find in a radian mode, not. So if you divided this number by pi, theta is going to be this number divided by pi is going to be equal. So that's what I'm going to check. This number divided by pi is going to be 0.25. But you have to be careful. That means you're going to say theta is pi over 4, which is right. This is equal 1 over 4. But you have to be careful. If you look at this point, negative, x is negative, y is negative, z is positive. That means if you look to the xy, it's on the third coordinate, the third quarter, because x, y is negative, z is going to be positive. That means the theta is going to be, what did we find here, which is pi over 4, and you have to add the pi. That means theta in this case is going to be 5 pi over 4. So now this is our theta because it's on the third coordinate. So here is the theta, but you have to add pi, which is 180. So as a graph, this is z, this is the z. So this is the positive xy. This is the second coordinate of xy. This is the third one. That means we're working on this coordinate, the point here. Here's the first one, the second one, the third one. The theta exists here on xy coordinate. So we have to add, we found the theta is pi over 4 here. We have to add 180 to flip the theta on the second coordinate. So it's going to be from here to this point, the origin point, or the x coordinate, not here. That means from x, we're going to go to here and stop. It's going to be our theta, which is 5 pi over 4. Now we're going to keep going to find the phi. Phi is going to be cosine inverse z over square root of x squared plus y squared plus z squared. Phi is going to be cosine inverse 2 square root of 19 divided by square root of 4 plus 4 plus 19, which is equal cosine inverse square root of 19 divided by square root of 27. Here is the important thing. How I'm going to find this one? This one is going to be hard to simplify. We can simplify because this is 3 square root of 3. So we're going to say phi is going to be equal cosine inverse square root of 19 over 3 square root over 3. I'm going to simplify this one more by rationalize the denominator. So cosine inverse square root of 19 over 3 square root over 3 times square root over 3 square root over 3. I'm rationalize the denominator. I need to make the denominator equal a number. Maybe it's going to be like more simple form. So phi is going to be equal cosine inverse. It's going to be square root of 57 over 3. Square times square is going to be 3. So it's going to be over 9. It's still hard to find. Even if you plug in, you're not going to find an angle. So just write down this. So I'm going to say phi equal 3 square root of 3 and theta equal 5 pi over 4 and phi equals cosine inverse square root of 57 divided by 9. So let's check this one. So we're going to say it's a 3 square root of 3, comma, and the second one is 5 pi. So 5 pi over 4. And the last one, here is comma, is going to be cosine inverse. So here is cosine inverse. And we have to put where's the fraction? Operation is supposed to be here. Division is going to be square root of 57 over 9. Let's check this one. Wow, that's good. So let's go to question 13. So from spherical, no, we have rectangular equations. We need to write down the spherical one. So y equal to, we need to write down the spherical equations. I already know y equal the whole sine theta sine, you can write down sine phi first, which is the same thing, but here is the formula. I'm gonna plug in these two here. So it's going to be rho sine theta sine phi sine theta. It's going to be equal to. Now I need to simplify it and keep the rho by itself. So I'm going to divide both sides by sine phi sine theta. Phi sine theta and divide this side sine phi sine theta. That's mean gonna cancel here. So it's going to be phi equal. Let's keep the two. 1 over sine phi times 1 over sine theta. So our is going to be 2. 1 over the sine is cosecant. 1 over the sine is going to be cosecant theta. That's it for this example. So let's keep here. It says, how I'm going to find the symbol? Because it's going to be, I don't know, we can write down P, the Greek symbol. This one here, equal 2 cosecant cosecant, go to the Greek symbol, this one, and cosecant again, theta. I'm gonna go to the Greek symbols, and where's theta? Here's theta, and that's it. Next question is going to be 14. We're gonna do exactly the same thing, and we need to figure out which one is going to be the graph. Oh, 13, 14. I'm talking about 13. So 13 is find the equation in spherical coordinate, and we have the rectangular one. So question 14. I don't know if we skipped one. No, we didn't. Oh yeah, here's a 12. This one is a 12. And this one is 13. So this one is x squared plus y squared plus z squared minus 6z equals 0. So the same thing, if you look to this part here, is the whole squared. That's mean whole squared plus minus 6z equal minus. We already know z equal cosine theta, cosine phi. This is the z. And we already know t squared equal, or the whole squared equal x squared plus y squared plus z squared. So I'm going to plug in this one here, and z by itself is going to be minus 6 cosine phi equals 0. Now, next step, I'm going to take this one as a common. So it's going to be 1 minus, going to be minus 6 cosine phi equals 0. So that's mean we have this one equals 0, or p minus 6 cosine theta, phi equals 0. This one you can't equal to the 0. That means there is no distance. So this is not acceptable. Just the other side, and we have to solve it. So p over the whole is going to be equal 6 cosine phi. That's it for this example. So we're just going to say this one is going to be Greek symbols, p equal 6 cosine phi. Cosine, there's phi. No, this one. This is for our question 13 or 14. The last one, they said whole equal 5 Now we have to check which one is going to be the right one. First of all, we have to write down the rectangle coordinate. So this is a question 14. They say the raho equal 5. That means to convert to the rectangle, because this is spherical equations. So I'm just going to say p squared equal x squared plus y squared plus z squared. That means here is going to be x squared plus y squared plus z squared equal 5. So this is the answer here, but then we have to find which one is going to be the right. This is squared plus y squared plus z squared. And this one is going to be equal 5. Now we have to find which one is the right graph. Why I choose this one? There's something wrong. So now we need to find which one is the right option. So let's look here. We can choose this one. We can choose this one. Let's look to this because it's a spherical coordinate. X squared plus y squared plus z squared equal 5. So this is 5. We're talking about xy. If you're talking about xy as a circle and z, both these equal 5. So if you look to this one, this is 1, 2, 3, 4, 5. I'm talking about x and y. So this is less than 5. This one is less than 5. I'm not going to choose this one. If you look here, just the xy coordinate, this is equal 5. This one equal 5. This one equal 5. And this one equal 5. And also, because plus the z squared also equal 5. So we're going to choose this one. That's it. The last two examples are the true and false. There's the wrong thing here. X squared plus y squared. Oh, I forgot to square this one. Because here's the wrong thing. Because this is p equal 5. That means p squared equal 25. 25. So this one is a 25. Yes, 2. And that's it. Last two questions, just watch this one. The first one, they're telling you a point in cylindrical coordinate is this one. This is not cylindrical coordinate because r, theta, and z. So this is false. You have to watch the video. And the last one, to find the equations in spherical coordinates, coordinate equations written in rectangular coordinate, use the relationship between x, y, z to rho, theta, and phi. That's right. We need to convert from x, y, z to rho, theta, and phi. So this one is a true statement. Submit, and that's it for this section. This is right, and this one's also. You didn't tell me. Oh, I didn't submit this one. Here's the submit. Here. That's it for this section.